Today's episode of Pipeline Things, we have our guest on where we get into AI, good data, bad data. Before we get there, we have to have some side conversations about Hulk versus Thor, Ticket to Ride versus Risk, and whether or not Lord of the Rings is better than Harry Potter. Spoiler alert, it's Lord of the Rings, hand down. But I understand a lot of you out there, including Christopher, feel very strongly
I did not pick a side.
Whatever. It's a great episode. We hope you enjoy it. Thanks for joining us. All right. Welcome to today's edition of Pipeline Things. I am your host, Rhett Dotson, my co-host, Christopher De Leon. Really excited to be with you. If you're not watching the YouTube channel, word of warning, I don't know if too many people understand the level of maybe nerddom that Christopher and I probably exist in.
If it wasn't for the podcast, no one would truly know much about us.
Yeah, it's
if you
true.
Think about it.
And if you go back and watch the earlier podcast, there's all sorts of Easter eggs planted all up in those that people probably aren't aware of. And we have some Easter eggs today. But the truth is, Chris and I are a bit of comic book nerds. I was even a video game nerd.
Yeah, same. Then computer game nerd. Yeah.
Anime nerds. In fact, whenever we found out that we played StarCraft,
it was kind of
together,
like, oh my God.
Then I found out he kind of collected comics. I mean, I still have a stack of comics in my mom's house, right? And so today we have the luxury, because of our guest brought it up because of his own ties to nerddom. We are shooting in Dragon's Lair, fantasy cards, and comics in Cypress, Texas off of Tomball. And they gave us this room, which is the coolest room we've shot in.
We have shot some things before.
Yes.
Now, so it is arguable if this was the right room for us to shoot in.
Yes.
Trip S. However,
did make a shortcoming there, but let's not share that with the audience. Let's keep her image.
This is a cool room. We got Zaron, the Night King,
and Mechagodzilla.
Mechagodzilla.
And for those of you who know Chris, probably in a past life or worked with him, for all of the ILI analysts who had to work with him while he was at Energy Transfer, it is completely appropriate that he sits in front of the Sauron Dark Tower image in this podcast. Like, completely appropriate. So, yes, but I love this. So, Chris, real quick. All right, lightning round. You like to do this, okay?
Oh, God. I have no idea what he's doing.
All right, brace yourself.
All right.
Because you got to answer quick. Who wins the fight?
Oh, boy.
Hulk or Thor?
Thor, hands down. No problem.
Wolverine or Deadpool?
Wolverine, no problem.
Spider-Man or Captain America?
Spider-Man, no problem. Especially Spider-Man 2099. Game over. It's simple. I thought this was going to be hard. No, I'm not. Look,
Iron Man or Batman?
Oh, Iron Man. But it hurts to say that because Batman's my dude.
Yeah.
Like, Batman's my dude. But I'd say probably Iron Man.
Yeah. Okay.
Probably.
I just wanted to check. I mean, we could waste a lot of time going into your reasons for those choices. I think Spider-Man versus Captain America is questionable. Yeah. But
okay, let me put it like this. Maybe he would be Peter Parker, but I don't think he would beat Miguel O'Hara. There's no chance. Spider-Man 29's got him. Sorry. We could debate that offline with a couple margaritas.
So on that note, I am going to bring our guest on, and we can ask him what he thinks about this environment that we're shooting in as well. But I am excited. So we're continuing on our IPC series here, and I'll just go ahead and bring him on. Our guest today is Mr. Adrian Belanger from TDW, and he is the author of the 2022 IPC paper, Not All Data is Good Data: The Challenges of Using Machine Learning with ILI. So that's what we're really going to be into in this episode after we cover some nerddom. So, Adrian, welcome to the show.
Oh, thank you very much.
So what do you think about this vibe, this environment?
This is a great place, man. I just told you guys I was in the gaming, and Chris said, hey, Dragon's Lair. So I come in here, and it's like, this place blows away any of the places I've been. Usually it's just a little hole in the wall, some comic books, a rack with some board games. Man, this is decked out, tables everywhere.
Yeah.
So this is also, you know what, I also think it's mildly appropriate. So as I said, there is another room that I felt was more appropriate for Rhett and I's personality. Hold on, but there is some redemption here, right? And the basis is, how many times have we heard that our customers feel like ILI is just black magic? You know what I mean? It's just like.
So you want to get into space magic? Is that what you're saying?
And now today the topic is this nebulous concept of machine learning. So the black magic just gets deeper. So I do feel like this room between the Night King and Sauron, it definitely feels
Mechagodzilla.
it feels appropriate.
We have it
going. Machine learning, the child of potentially both of them, right?
Yeah, and I'm not sure if that's Frodo or if about to drop the ring
or
right into the
Gollum or
it could
somebody.
be Gollum right before. Anyway, Adrian, welcome.
Yeah.
So we're super excited to have you. So tell us a little bit about. Go ahead and introduce yourself to the audience if you don't mind. Who is Adrian? How did you accidentally find yourself on this podcast? All the above.
Oh, okay. Well, I'll give you a little background how I got into ILI. I started off wanting to go into physics and didn't find too much job opportunities with a bachelor's in physics. So I went back from medical physics, went into MRI, but living in Houston, I was looking for other job opportunities and discovered this strange thing called inline inspection. And once they showed me what you could put these tools and magnets on there, I was hooked. So I started at Tuboscope, worked to Tuboscope all the way up till it's...
That's a Tuboscope, 90s, 2000s? What is
I
this?
started working 96.
96, okay.
Yeah. So that was when Tuboscope was not acquired by anybody.
Mm-hmm.
And
that was
then,
a Linalog.
Yeah, Linalog. Yeah. That's right. Yeah.
That's how when
I
started.
remember
I looked at a lot of Linalog
we had
data.
books, but we still had to go back and get the scrolls and look at the paper. And then in order to measure a dent, you had a little cardboard card of a little clear plastic with 3 little lines on it. So you had light, moderate. You only had to grade the deepest one in there, and then you just only did the welds for the 3 upstream, did 3 downstream.
Wow.
So
were you an analyst? Did you work as an analyst?
I started as an analyst, but then when I started...
So a degree in physics, and you're working as an analyst for 2. That is
you got to start at the
incredible.
bottom, work your way up. So, but because my physics background started solving some of the problems in life, so I quickly went to engineering and started coming up with the algorithms for the grading and the sizing and the tools that Tuboscope was using. And then Tuboscope had a partnership with NDT, which is now NDT Global, but it's the former NDT Global. And so worked with some UT tools and loved that stuff. Was wanting to get the synergy of the data. But that's when NDT kind of went bankrupt and I came over to TDW because they were like the next generation MFL tools here in the United States. And we worked with James Simic.
Yep.
He brought the SMFL over there, so I just immediately attached to that. And they incorporate the low field magnetization. That was I'd worked with Patel back when I was with Tuboscope. So I just continued on from there, and but still running into many of the same problems we had before, where you don't get the dig feedback unless it's wrong.
That is the most common theme.
Yeah. So as we start moving into the age, but TDW had a lot of dig feedback. So they were actually, we were actually modeling our stuff on actual field data. Whereas before, I was always making the algorithms off, and you machine a pit into a pipe, and then you do algorithms off that, send the tool off, do a prediction, and then...
So looking at the paper, was that the genesis? Was the genesis the volume of feedback that you get? Or the
genesis is the quality of feedback, because with TDW, even though they had lots of dig feedback, the quality was still, you get this report, you got a depth on there, a picture, and NDE guys in the ditch are not the best photographers in the world, so you're not getting, is that the pit that you measured?
If you get a picture.
Yeah, if you get a picture. Speaking of which, I remember when we had rubbings, they would do the rubbings, and
I did not know they did rubbings in the field. I learned something new today. I never knew.
Which
we
was
did
actually
rubbings.
very helpful, because then you could actually line it up with your signal and go, oh, that is this guy here. We were sizing this one here.
Wow.
Yeah. So there was a lot of human interaction with that. So coming up in the age of machine learning, though, you got to start automating this stuff. You can't be having analysts, doing all this stuff by hand all the time.
Yeah.
So,
is it fair to say, I mean, at TDW, like, one of the reasons I chose your paper was the focus around machine learning, because I hopefully it doesn't offend you, but I feel like that is a buzzword in our industry. Like
definitely.
I told you before, it feels like it's thrown around everywhere. I've seen machine learning for nothing more than linear regression, like, How is TDW, or what is your involvement with machine learning and ILI? How are you using it in the context of this paper? What are you guys using it for?
It's tailored to the problems that you're trying to solve, and that's kind of what that paper was about. I wanted to kind of like demystify it, so we went down all the different types of machine learning. You know, you have your tree learnings, you do your convolutional neural networks. It depends on the type of data you're doing. A lot of the type of dig feedback we get, the tree decision trees are the better, because you're only getting very sparse information, length, width, depth. Whereas if you get a full laser scan, then you can start doing convolutional training on it. So it depends on the type of data you're getting. So what we mostly do, because we're mostly getting our dig feedback and Deformer reports, we're using like GPT. I'm sorry, that's the buzzword on my mind. We're using gradient boost, which is a type of decision tree for it.
I had no idea. Honestly, I wouldn't have known the difference between the two of those if you would have told me. In fact, that's the first time I didn't. And you realize you just mentioned decision tree, which kind of made sense, and then you mentioned a gradient one. So you're telling me that out there's obviously different types of AI models.
Whenever you can tweak or tune a way to train it, you got a new model. So that's why there's just tons of words. Everybody who does something a little bit different publishes a paper and gets a model named after him. So gradient boost is based on the boost. They're just using the gradient to solve it faster. That's all. So
Gotcha.
Yeah.
So I'm just curious, right? Again, because AI is the rage, right? At one point, I remember talking to an analyst actually from Baker Hughes, and I think she'd been there for like 30 plus years, and she joked that somebody said 20 years ago, your job will be replaced by a computer. She's like, here I am, 10 years, 20 years later.
Yeah.
Is this the type of thing when you talk about using machine learning? Is the vision to replace it? How do you guys see it working?
It opens up more problems that you can solve. So most of the bread and butter of ILI has been corrosion, right?
Yeah.
You're just size and corrosion. But now there are a lot of integrity threats where we're kind of iffy, but mechanical damage, hard spots, seam welds. You really need the analyst go in there to kind of say, well, this one probably looks more susceptible than that. So once you get the machine learning in there, you start making those problems actually tractable. You give real data for analysts to work with, so they can start making more accurate decisions. And one of the biggest ones, like one of the most hardest ones we've had to deal with, I know a lot of people probably know about supervised and unsupervised learning. So the stuff we're doing is supervised because you have labeled data, you know what the actual dig feedback is, so you're trying to match it. But let's say when you do the traceable, verifiable, and complete records, you get these signals on pipe. They're incomplete because no one knows what that pipe is. So you go in there and you're trying to take the signals from each of the joints of the pipe and find patterns in it. If you don't know what those patterns are going to be, you need the machine learning to go in there and say, hey, this repeats, this repeats, this repeats. It doesn't show up here, so that's different. So if you had an analyst do that by hand, they might find some of it, but the machine learning can really go down and find some real subtle features that an analyst might miss.
Interesting. So it's like putting an analyst on, like making a super-powered analyst. Maybe giving them a suit of armor or a Batman belt, or maybe
it's Jarvis, bro. Come on, aren't you Iron Man? Like, it's Jarvis. Come on, how do you not home run that?
Is that what you see going on? Is that what's going to happen at TDW? There'll be a whole bunch of analysts in the room. They'll be
I like the utility
Jarvis
analogy.
Yeah,
that's the best one.
Yeah.
Jarvis, is this corrosion?
It's like, it's not Alexa.
Well,
it's not Siri.
Jarvis, though, so.
It's true. He comes Ultron and great. That's true.
Yeah. But one of the things I appreciate about some of the things you said, Adrian, is our customers a lot of times trust the ILI system as a whole, right? And they trust the passion and the innovation that the ILI community has brought for the last 30 years at least that we've had the privilege of witnessing. Not that we've been in for 30 years, but we've worked with a lot of technologies that manifested in the 90s and so. And you mentioned that it allows the analysts to kind of solve different problems. And you can imagine a customer sitting here trying to evaluate 5 different service providers, 5 different technology types, all with different offerings. And now we throw AI into the mix or machine learning. And so it might be hard for them to appreciate what problems are actually being solved. And I felt like you kind of started going into that. One of the things that the way I like to frame it, maybe you can add to it, is it's, terminology that we're very used to is like an automatic feature search. customers might be used to that, right? Where you ran an ILI tool, the tool performed well, and the analyst will say, hey, we can be on schedule for this analysis to meet your reporting timeline because the automatic feature search only produced this many features. So we're estimating we can get this out on time. When we think about machine learning, a lot of times I feel like there's different tasks, broad tasks that we see that machine learning is helping analysts. Maybe you can elaborate. It's, for example, classification. Like, are y'all using it for the perspective of like identifying things like girth welds and reference points? Or is it more towards saying this is corrosion? Or is it even a step deeper where you guys are saying we know it's corrosion, but we use our machine learning to appropriately size it?
You threw out multiple different things there, but that's good because, like, let's just take the simple one, girth welds. You don't really need machine learning for that. Yeah. That's actually just a simple algorithms you can go in. The patterns are very significant. Now, if you want to like find girth welds that might be susceptible to cracking, that's where you want a machine learning that could say, okay, I have a probability that this guy may have a crack in it. These guys don't, and so you can bin it. And then there's metrics you can do with that. So you can they're like called hyperparameters. So you can tune like, I can handle false positives. I don't want to miss anything. Yeah. So when you say this is clean, you have like 99.9% confident this is clean, and then you can focus on all those other guys. So and that's quantifiable. And that's verifiable. You can measure that.
So you're also leveraging in the idea of using machine learning for this application. It's what I almost call like the metadata or parameter data, and not just the ILI signal data.
Each one of them, you'd have a model for each problem you're trying to do. Yeah. And then you're talking about the meta would be like the suite that you have all these guys in. Yeah. And to take even further, because I get really data focused. I mean, so like with ILI, it's you can also do your records. You can I know, like, I think TCE had something at PPIM about how they're actually using ChatGPT to go through all the documentation in the company, and then so you can look stuff up. And it's like, so like in our company, there's so much stuff that's documented, but it might be over here, it might be over there, and it might be on a different server. So if you have a machine learning that is like on the ChatGPT level, it's like, okay, I'm looking for this keyword, and it goes and scans it all, puts it into a nice little concise report for you. Yeah. Boom. That just makes your work a lot easier. And then you're not wasting.
Dude, their PRCI literature reviews just got replaced. We just need to take all the PRCI documents, dump them into one thing, and have ChatGPT go through them. Yeah, well,
at the risk of offending PRCI, it's much better than what they got now. That would be really helpful.
Oh gosh.
Well, I mean, obviously we see the advantages of machine learning, right? I mean, if anybody's ever invested any amount of time looking at ILI data, God bless and thank you for all the analysts, right, and the algorithm developers, because sometimes it does feel like a needle in the haystack, right, where you're looking for small indications, and as a community, we rely on innovative tools like machine learning that are able to find patterns in some of the small scale stuff, right? Or in patterns that an analyst just visually and manually will struggle with. And I think you kind of mentioned that, right? It's like where you can apply observations across a larger data set to find truth, kind of is the idea, right? And that's what you're pulling out from using the machine learning.
And the AI doesn't tire. So analysts may have been doing like overtime to get this job out. So, and they're having to scan through the if you have a machine, just run it through the machine, it's scanned it looked at every data point for you. And it's reduced it down to a small subset that the analysts has to spend.
I like the assistance aspect of it. The assistance aspect of it speaks a lot to me and where its value is. But I tell you what, we're actually going to take a break. When we come back, audience, we're going to dive into how is the data that's good, what does it look like as it goes into ILI, and what does bad data look like? And we're going to dive into that with Adrian right when we come back. All right, welcome back to our IPC series with our guest, Adrian Belanger. So, Adrian, before we get back into AI, I have to do the same thing to you that I did to Christopher, which is lightning round. I'm not going to ask you about comic book characters, though.
Oh, all right.
You said you're a board game guy.
Okay.
Or you said, so let's go. Monopoly or Battleship?
Battleship.
That is the right choice. If you said Monopoly, I was going to
Monopolies cause too many domestic violence events.
So that's for the record. That's Uno for our family, bro. Uno brings out the worst in people.
You can turn Uno into a drinking game. It's fun.
Yeah, with the blank card that you write something on. Yeah, I'm with you.
Ticket to Ride or Risk?
Risk.
Okay. And you might not know these.
To be honest, I never played Ticket to Ride.
Okay, all right.
I know it's popular, but I've never played it.
There's about 7 variants of it. You probably haven't played this other game then. King of Tokyo or Scrabble?
Oh, I'd have to say King of Tokyo.
Oh, all right.
Yeah.
There we go. Got a little flavor for who Adrian is. Sorry, just had to ask. I couldn't go with any of the real deep board games because the audience wouldn't recognize them. By the way, audience, if you ever did recognize those games and you haven't tried out Ticket to Ride or King of Tokyo, you should give them a shout. So, or Risk if you must. But Risk is more fun on we have the computerized.
My childhood
game board.
memories of Risk. It's just.
But you know how fun it is to play. We have the game board now, the digital version of it. You just play on a touch screen.
Yeah.
It's so much faster because you don't have to argue over points or how many armies go where or roll the dice every time.
I love
it's
the
not
little
AI.
Cannons and the little horses.
There's something about the motion of
tactile
trading
3D.
in. Where you're trading in pieces to get a cannon.
But you know what happens? Whoever ends up losing ultimately blames everybody else for ganging up on them and quits the game.
That's usually why they lost, though.
All right, so getting back into our AI trend here. So let's talk a little bit about it, because you guys get feedback from vendors, and the purpose of your paper was not all data is good data. So let's start with, what's the gold standard for data in the context of this paper?
Well, the gold standard would be to have an accurate representation what's actually on the pipe at every XYZ coordinate. So that, because think of it, it's a digital twin. We're trying to create a digital twin of your pipeline so that you can do an integrity assessment of it. So if we're only getting a depth in a box, you're going to get, when we model it, you're going to get a pipeline with square metal loss boxes in there. And that's not a good integrity assessment. Yeah. So what you need in the ditch, you need some sort of laser scan if you have external, and if you have internal, some sort of automatic UT scanning.
And so with that data, so you mentioned, let's take a complex corrosion pit. So length and width and depth. Those 3 variables on one hand, minimum feedback.
Minimum, yeah.
Versus your gold standard, which is a fully spatialized representation of the corrosion. What can you do when you have the fully spatialized laser scan? What does that then permit you to do? Why is it so good?
What that allows us to do then is that there's a whole group of machine learnings called convolutional neural networks. And what you can go in there is you can go and process. I'm biased for MFL, but you can do it for UT too, to remove just the little inaccuracies maybe you have in UT, but UT's more direct. But with MFL, what you're trying to do is you're trying to do an inverse model of the magnetic flux leakage to the metal loss. I know Johannes from Grozen had a really great paper about how the 2 magnetic fields is. You can recreate that. It also allows us to go and do finite element modeling. You can get the magnetic flux leakage from the finite element modeling of that metal loss, and then start working on inverse models to go backwards.
Gotcha. You know, so on the subject of data, and I'm curious, right? So obviously, if you've got the fully spatial data, now it really allows you, what I'm hearing in layman's terms is a much better understanding of the magnetic response and ability to maybe predict or characterize other similar magnetic responses. Is that fair?
We call it the no pose problem, because a magnetic flux that's generated can be generated with multiple different geometries.
Yes.
So what we'd like to do is just, what is the typical geometry that's of corrosion that's out there? It's more like the most likely geometry you have, because the other geometries can be kind of bizarre looking. Sure. Yeah.
And you mentioned a statistical representation earlier when you were talking about this feature has a 90% chance of being this. So with that, is it fair to say that you see it giving the analyst statistical, this feature is a 90% probability it's this type of feature or this classification?
Yeah, you can do that. And actually that's where Baker does that with they're doing it because they have that they have a whole library of that laser mapped data. And when you see it multiple times, you see how likely it is that the MFL signal is being generated by these different geometries.
Interesting.
Yeah.
That's cool. So on the flip side, what does bad data look like? If not all data is good data, give me the bad data.
The worst cases are where you're getting, on your NDE report, you're getting the depth off of what was not called by the ILI. It's in a different area. A lot of times there's just a mismatch from the field and the ILI data. That's bad data. The other data is not necessarily bad, but it's just inappropriate. Like if you're going in and you're only measuring the deep stuff, but there's some light corrosion on there, it's just missing data. I mean, you have the ability to get that data, but it's not there. Which also makes it more difficult to match it up with the ILI if that's data is being excluded from the report, so we don't have a reference to match it up to. So it's more missing data.
So how does that function in AI? I assume when you're doing these types of models, you guys must have to heavily screen the data before you feed it to the AI, because you got to make sure that the AI is understanding it.
Well, that's one of the problems we get is we get these things on a paper report. They get hand entered, so you can see there's errors in there. So when on the machine learning side, when we're actually training it, we're looking for anomalous ones that just, we have to go back by hand, look at the report, look for the picture, look and make sure that somebody made a fat finger the depth. So that data has to, so it's the curation process. If you look at any of the kind of one of the machine learning where they break down the tasks they're doing. Very small part is done on actually training and building the model. Most of it's data curation. It's knowing your data and making sure your data is clean. Yeah.
Another question I have for you, and this is intriguing to me because you mentioned earlier in the first half of the podcast, you said something about the fact that, and it's on my heart, we only get data when we're wrong, right? And I felt that way when I was at Rosen. I used to tell operators, it's almost like we create scarred. We create scarred analysts because the only time you ever call your analyst is when he's wrong. It's to berate them. Yeah, they don't want to talk to people. They always think every
or
time
to ask
you call
him when the report's coming.
Yeah,
one of the two.
If you have nothing else in the podcast, please call your analyst more than when they're just wrong or when to ask.
Think about mental health. Every time the phone rings, it's like, oh god.
Yeah, exactly. It's yes, absolutely. It's Pavlovian response that we're creating there. Only it's not a salivating dog. It's a scared analyst. But on the data side, I'm curious if all we ever get is feedback when it's wrong. Does that bias the models, right? Because to look at a data set, don't you need a data set that covers both ends of the spectrum, the good and the bad?
You do, yeah. You need data that just covers everything. What that's doing, it maybe doesn't really bias the model so much, but it becomes ineffective because you're not really knowing how off you are on the good stuff. Because you could actually improve your accuracy on there. Another fact too is like when we get most of the dig feedback, it's usually between the 20 and 40% depth range. What you really want to do is be accurate on the 60s and 80s. And you don't get a lot of dig feedback on that because usually they get repaired right away.
Interesting. Yeah. That's true. So they go in the ditch. They don't see a need to scan it because they know they're going to put a thing. So don't spend the money on scanning it. Just put the sleeve on it or cut it out and move on.
Yeah.
That's interesting.
When we think about machine learning, I often think about like whenever we have a growth opportunity or an evolution of technology, there's value created. In your opinion, do you think that value you feel like is more received by the analyst right now? Like they're more excited about it because they're able to say, ooh, look at all these cool things I can do now. And maybe that doesn't translate to the customer as directly, or do you feel like maybe your feedback that you've gotten from the market is the market's really appreciating all of this AI? Are you on the which one of those two do you feel like is really appreciating it more?
It's always marketing driven. So analysts do want it, but analysts are skeptical because they're going to. It's I'll wait and see. How is this really going to be that accurate?
Is this taking my job? No, it's not.
Well, I think it's more. Can I trust it?
Yeah, that's true.
When it gives me this depth and I'm looking at it, do I trust me as an analyst or I trust this AI?
Yeah.
You have no idea how close that is to my heart because that's a recency bias, right? So when we draw on information, like fun fact, if you want to know what people will think about something, you ask people to think of a number between 0 and 20, and then ask them to give you an answer on something totally irrelevant, something else like, what do you think the population of something is, or percentage of this people, they will always give you an answer that's closest to that last number they thought to, because our mind draws on recency.
Yeah.
The same thing I witness happens all the time in engineering assessments or analysts, right? So if you bias the analyst with an initial indication one way, we saw it on bending strain whenever I did it, where I said if you shade something as a field bend, the analyst will be inclined to think it's a field bend, when in reality it might not be. So I think it is actually, there's something said about the AI has to give the right indication to the analyst.
AI
the
is
analyst
susceptible to that too, though, because if you know the big breakthrough like ChatGPT is attention. That was the big paper that came out. Attention is all you need, that Google did. So what it is it's the window of attention that you have. If you're chatting with ChatGPT, after a while it starts to forget the early questions you have, because there's a window that is relevant to it. And the same thing happened like in the early days when we were doing like neural networks. We were training it on these features and then retrained it on another set of features. It lost its accuracy on the old features because it's having to adjust its weights for both of them. So when you're modeling these things, you need to make sure that you're always incorporating, you're weighting things properly and incorporating all of the data that you have, so it doesn't forget things.
Because obviously with our previous employers, you know, a lot of the value that I personally, these are personal experiences, guys, right? I saw a ton of value on the analysis side, right? In creating reliability, creating consistency, helping analysts go through complex processes more efficiently. So like through classification and grouping, you know, so you instead of an analyst, think of like in the early days, and maybe even to some degree now, you start at the launcher and end at the receiver, right? So linearly, you're like, oh, I've seen this pattern. Let me apply what I've seen currently. Yeah. Whereas some of these machine learning classification technologies can say, hey, they grouped all these for you already. Like all of these features are near girth welds, right? And so now you're punching out only the features that are within some tolerance of a girth weld. So your attention is on right now I'm analyzing features near girth welds, not I had a girth weld, now I'm in the middle of the pipe, now I saw a dent, now I saw something weird, and I'm back at another girth weld, right? But you're able to focus your analysis not across threats, but across different classification types, right? Not classification as is this metal loss or not, but this type of interaction or this type of flaw. And so what it did is we saw all these opportunities for it to create reliability, consistency, and efficiency in the analysis process. And as a customer, when you think about maybe the marketing or the value add, it was, well, I thought you guys were always good, you know? And it was, well, this is just a step forward to ensure it, right? And that's why I brought the question around, you know, do you feel like the analysts today are more excited or maybe the clients? Because I feel like, you know, it just depends, you know?
The analysts are excited if it can take work off their workload.
Makes sense.
And then they have to develop the trust in it that they can just go forward. They don't have to double check it.
And but and then obviously as we get more data sets and you're interacting different signatures and you're trying to bring all those together into one plain view, then obviously machine learning starts helping with those type of things. And so I feel like that's maybe the next step.
But I think what we'll see then is evolution of the integrity assessments, because integrity is still doing. We gotta have these grouping rules, right? These boxes and stuff like that. Interaction rules. When you start looking at the actual corrosion itself, you can actually just start modeling the actual integrity straight from the actual corrosion profiles. Kind of like the way P-square is going. When it's you know, you're doing the river bomb, but you're taking into account everything.
So, Adrian, as we close out, I did give you a chance to think about this.
Oh, I got a question for him too, so you go ahead.
Okay, I was going to give him 3 requests you would make of operators for good data. What would be your top 3 wish list?
Ours was kind of similar, but I'm still going to ask mine anyways, I guess.
Like if you were to tell somebody, hey, if you do nothing else, this is what I want most.
Yeah, but you gave him 3, so I'm going to piggyback on that. Let's say you collected all the Dragon Balls. Because that's what I was going to ask. What would you wish for in this subject, on this topic, right? And obviously, so you have to choose one.
You get 3 wishes. There
but Rhett gives you. Yeah, but now you're getting 3 wishes.
If you can't think of 3, you can do 1 and take this.
No, 3's fine because I'll break it up into different integrity threats. I think I'm always going to fall back on laser scanning. So getting the laser scan for corrosion, and then the second one would have to be for the automatic UT for not just going in with the let me find out where the deepest depth is with the hand or gridding it out. But getting that full matrix of what does the ID look like. And then the same thing for depths too. That way we get away from the bridging bar problem because we're always having to calculate.
It's as long as bridging bar.
Yeah, it's just mapping out what is that actual XYZ of the outer surface of the pipe.
Okay.
Yeah.
Well, before we go, I have one last question, but it's not to you, and it's not to Chris. It's to Trip S. All right, are you ready?
Okay.
And I'll read Chris, you can repeat her audience.
All right.
They probably can't hear her. Trip S, here we go. Lord of the Rings or Harry Potter?
Harry Potter. 100%.
Lord of the Rings or Harry Potter? She said
Harry Potter 100%.
Harry Potter 100%.
That is, I almost want to stop there, but we won't.
Yeah, wait, are you going to ask who would win in a fight in either one of those?
No,
Voldemort or
there's
Sauron?
There's no question. No.
My fiance is a Lord of the Rings guy.
Well, he's a good man. Star Wars or Star Trek?
Star Wars or Star Trek?
Okay, my dad's a Star Trek-y guy. Like, I have to say Star Trek.
Okay.
Star Trek.
That's
Out of loyalty to her dad.
Because she probably hasn't watched either one. That's what I took. Audience confirmation. She hasn't watched either one. Marvel or DC?
Marvel or DC?
She was like, what are you talking
Marvel
about?
for sure.
Marvel for
DC
sure.
should do, I have strong opinions on this, actually.
She has strong opinions on DC or
Well,
Marvel?
you know what? You might, audience, have to come back for another episode, maybe a guest episode, where we interview Miss Producer and talk about the difference between Marvel and DC. For the time being, Adrian, I want to say thanks for joining us on this show. It's been a lot of fun. I want to say thanks to Dragon Slayer for letting us have this use this beautiful room.
Yeah.
And we hope you enjoyed us as we nerded out a little bit with Adrian. Catch us again in 2 weeks on Pipeline Things. All right, this episode of Pipeline Things was sponsored by D2 Integrity, produced by our executive producer, Sarah Roberts. We'd like to give special thanks to Dragon's Lair and Tomball for letting us use their rooms for the recording, and to our guest, Adrian Belanger, for being on this episode. Thanks for listening.